Welcome to Certain where we make sure and double sure. In this video, I'm going to look on independent defense. This is one of my videos in applied probability and statistics. If you need another video, check in the description. I have a full playlist. What we're going to do, we're just going to look at an example which requires application of independent defense. What do we have today? A system composed of n separate components is said to be functional when at least one of the components function. For such a system, if component I independent of other component function with a probability pi, where I is equals to 1, 2, 3 up to n. What is the probability the system functions? We have two things right here. The system will function when at least one of the components is functioning, or the system will not function when none of the components is functioning. So I'm going to let the event that component I is functioning as Fi. That means if component 2 is functioning, the event is given by F2. If component 10 is functioning, the event is given by F10. So that means if F10 is not functioning, the event is given by F complement 10. That means it is not functioning. So I'm going to represent this using a T diagram because it is easy to understand. So I'm going to write my T diagram here. We're going to have two things. Either Fi is functioning, right? This can be component 1, component 2, component 3. Or Fi is not functioning, which I'm going to represent by F complement I. Now from the question we're told that if Fi is functioning, the probability is given by Pi, where I is equals to 1, 2, 3, 4, 5 up to n. So we can write the probability as Pi. What about the probability that Fi is not functioning? We know that some of the probabilities should add to 1. So that means the probability that Fi is not functioning is given by 1 minus the probability that Fi is functioning. This is what we have. So from our question, we know that the probability that the system works is equal to 1 minus the probability that the system does not work, right? So if the system does not work, that means none of the component is working. We know that. That means F1 is not working. So what is going to happen when the system does not function? We said F1 is the event that the component I, we said Fi is the event that the component I is functioning. So if component I is not functioning, that means we're going to have component 1 not functioning, component 2 not functioning, component 3 not functioning, component 4 up to component n. And remember I was saying component 1 and component 2 and component 3. And in probabilities, when we say and, we multiply. So that means I'm going to say 1 minus the probability of F complement 1 times F complement 2 times F complement 3. We're going to add all parts up to part n. We know that F complement R is given by 1 minus Pi. So that means for component 1, it's going to be 1 minus P1. Component 2, it's going to be 1 minus P2. So let's write that. Okay? So this is going to be a product. So we have a way of representing it using the capital letter pi, right? So what I'm going to do, I'm going to say 1 minus, we know that I ranges from 1 to n. And it's going to be 1 minus Pi. That means if I want to find the probability of component 1, we're just going to substitute 1 into our formula and we're going to multiply. So it's going to be 1 minus P1 times 1 minus P2 times 1 minus P3 up to 1 minus Pn. Right. So if you have enjoyed this video, I hope you subscribe. Thank you for watching. If you have any questions, the comment section is yours.